Alright class, welcome to the video for Math 2015 Learning Outcome 9 Homework Hints. In this video we'll go over a few of the homework problems so you can get a better idea of how this homework is working with writing expressions with variables from given situations. Focusing on the fact that we want to write as few variables as we can in our expression if possible. So first one we'll do is 15a. 15a says, and the directions say, write an expression for each of the following things. If it is possible to use only one variable when writing the expression, do so. I want to identify any variables you use. Okay. So Farmer Brown has a total of 12 animals on his farm. The animals are either ducks or cows. Write an expression for the total number of feet on Farmer Brown's farm. So ducks have 2 feet and cows have 4 feet as we think about this. So when we write an expression for the number of feet, we also have a clue that there are 12 animals on the farm. So let's let D equal the number of ducks on the farm. Okay. Notice that we're using number of ducks for D instead of just ducks. Precise definition of a variable. Let C equal the number of cows on the farm. We know that there are 12 animals on the farm, so we can write this equation, D plus C is equal to 12. Our goal is to write an expression for the total number of feet. Okay? So the total number of feet is equal to 2D plus 4C, because we have 2 feet for every duck and 4 feet for every cow. Okay, so this is actually an equation technically. Here's the whole equation. This is the expression that they're looking for. Now, is there a possible way to have the expression with one variable instead of these two variables? If this piece of information wasn't here, if I didn't know that there's 12 animals on the farm, all I have to go off of is D and C for number of ducks and number of cows. And so the total number of feet would it's only possible to write it with with 2 variables. There's no way to simplify it more and write it with 1 variable. But since I know that another relationship between D and C and 12, I can rewrite this expression, C plus D, in a different way and then substitute it into my original expression here for D or C. So let's take our D plus C and solve it for one of the variables and then substitute it back into our expression. We have D plus C equals 12. Let's go ahead and solve it for D, which means that D is equal to C, 12 minus C. If I subtract C from both sides. Okay. So D is equal to 12 minus C. Now I'm going to take this 12 minus C here and put it in for the D up here. Okay. So what I'm going to do now is do that substitution here. And when we do that, we get so that will equal to 2 times 12 minus C plus 4C. Okay? And so that's my new expression for total number of feet with 1 variable. Okay? Okay, so it could be, so we're going for just the expression. Let's take that off. Just go around like here. Okay. So our total number of feet can be expressed with 2d plus 4c. Total number of feet can be expressed with 2 times the quantity 12 minus c plus 4c. And I can actually take this d plus c equals 12 and rewrite it in terms of c. Let's see what happens when we do that. D plus c is equal to 12, therefore c is going to equal, let's subtract d from both sides to know. Those will simplify, and c is going to equal 12 minus d. Okay. I'm going to take that and substitute it into my expression for total number of feet. Oops. Okay. So here's my third option here. For the homework, you want to generate this first one, and either this one or this one here will be sufficient. Okay, class, the next one will be number 15b. Come on now. 15b says, 5 children are at a sleepover. John and Sarah bought the same number of stuffed animals. Lauren bought twice as many stuffed animals as John and Sarah. Denny and Arlen both brought the same number of stuffed animals. Write an expression that captures all the information in the problem and gives the average number of stuffed animals brought by each student. So what we have here is we have some variables. John and Sarah bring the same number of stuffed animals. They both bring some stuffed animals. So we can say that x, let's start with x. X is going to be equal to the number of stuffed animals brought by John and Sarah. We're going to use or Sarah because they both brought the same one, same amount. And then a different amount of stuffed animals, so both x and y are referring to stuffed animals. Brought by Denny and Arlen. Denny or Arlen, because they're both okay. Now, if you notice, we didn't mention Lauren, but because she brought twice as many as John and Sarah, so she's just 2x is all. Okay, so I'm going to write this down here. So Lauren is 2x. Oops, not. She is not 2x. So 2x is equal to the number of stuffed animals brought Lauren. Okay. So we have all of these variables here assigned. Now the point of this is we want to write an expression that captures all the information and gives the average number of stuffed animals brought by each one. Okay. We want an expression that captures all the information. So we can find how many everybody brought. So the total number of stuffed animals is an expression, and usually we're used to having numbers for these, like let's say John brought 5 and Sarah brought 5, so they had 10. But we're going to work with variables. Even though we don't know what they are, we can still work with them. Okay, so the total number is the number brought by each person. So John brought X, Sarah brought X, Lauren brought twice as many as one of them, Denny brought Y, and Arlen brought Y. Okay, so we've added them all together. We don't know the total, like in the first problem, and so there's no way we can relate X and Y together. Okay, so I'm going to go ahead and label what we have here. So this is the number John brought. This right here is the number that Sarah brought. This is the number that Lauren brought. This is the number that Denny brought. And this is the number that Arlen brought. Okay, so we've added them all up, so that's the total. We can put n equals here. Now our next goal is to find the average. If you recall, the average brought by each person, the average is, that's what the equals, the total divided by the number of items. So we're going to do total items, total amount, let's just say amount, divided by the number of items. Okay, so we have the total we just calculated. Okay, so we're going to do x plus 2x plus y divided by the number that there are. So we're doing the average for each child. So there are 5 children. So we're going to divide this by 5. So average is total divided by the number of items. We divide that by 5. So x plus 2x plus y is the average. In these equations, we need to kind of also label our variables. Okay, so I've equated, or I've said that x plus y divided by 5. Let's remind our readers what the variables mean. Where x is the number of stuffed animals, brought by John, and by consequence Sarah as well. And where y is the number of stuffed animals, brought by Denny, and by consequence Arlen. Okay, so that's sufficient for this one. All right, class, the next one we'll go over is 15G, and this is what 15G says. A class is composed of some number of freshmen, a different number of sophomores, and yet a different number of juniors. So there's 3 different variables here. The average number of times a student attends office hours is 1.47 times per week. Write an expression for the typical number of students that visit office hours in 1 week. Okay, so we we want the total number of typical total number of students that visit the office hours. Okay, so average. So first of all, let's think about what variables we need. The class is composed of some number of freshmen. So we're going to let F equal the number of freshmen in the class. We're also going to let S equal the number of sophomores. And then we're going to let J equal the number of juniors. Okay. So all of them together, the total number of students that visit the office hours is all of them together. Okay. So we're going to say, okay, the next piece of information they give us is average. Okay. So average. The average number of times a student visits, a typical student visits. So let's see here. So the average of each student is equal to the total number of students, and the number of times, total number of times students visited, I'm going to not work for that. Let's get this over a bit. Divided by the total number of students. Okay, so the average that students visit each week for office hours is equal to the total number of times that students visited divided by the total number of students. We know what the average is, so the average is given us as 1.47. Total number of students total number of times students visited divided by total number of students. So we got that as 1.47. Okay, let's go ahead and scoot this down just a tad. I can get around it here. I can separate those good. I can see that better. All right. Now our goal is to get the total number of times, total number of visits, that is, which is the top number here. This is what I want. I want this right here. Okay, that's the number I want. I need to express the variables as well. Okay, so total number of students, let's change this one down here. These will go down here. And so we can say that 1.47 is equal to the total number of visits. So we'll shorten that up a bit. Divided by the total number of students, where I input my variables, substitute in my variables, F plus S plus J. Okay. So I need to get the total number of visits again by itself. So it's going for this part. In order to do that, I need to multiply both sides by F plus S plus J to get the numerator by itself here. Okay. And so we'll go ahead and write the total number of visits. Oops. is equal to the 1.47 times F plus S plus J. Okay. And that's what our goal was. Now, once we've said F plus S plus J in our expression here, we need to label the variables. F equals the number of freshmen. S equals the number of sophomores. And J is equal to the number of juniors. Okay, so there's that one. All right, class, the last one we will do for this video is 15H. It says, Anne is 4 years older than Bill. Carmen is 1/5 as old as Anne. Dana is 4 years older than Carmen. And if Bill is B years old, what is Dana's age? Okay, so there's a lot of things going on with this one. And my recommendation is to start practicing modeling with the bar model, what is going on in the word problem, so we can know which operations to do to which quantities. And it helps us sort them out, and especially since we don't know a lot of the numbers and letters, okay? Numbers for the letters here. All right, so it says that Anne is 4 years older than Bill. So we need to draw Bill, and we need to draw Anne to be 4 years more than that. So let's use our bar model to help. So Bill is this old. Okay. And we have Anne is this old. Okay. That's 4 years. All right, so Bill is going to be blue. So I'd like to color these bars here so you can see the differences in them. And Anne is going to be red. And her difference will be pink. 4 years, okay? All right, so there's Anne and Bill. The next part of our story says that Carmen is 1/5 as old as Anne. So we take Anne's bar and then divide it into 5 equal pieces. Okay, so we're going to take Anne's bar and divide into 5 equal pieces for Carmen's age. So here's Carmen. So you move her down a little bit. Okay. Now Carmen is, take Anne's bar distance. This is all of Anne's bar here. I'm going to shade 1/5 of it. So we have to kind of guess here. 1, 2, 3. So I need to take this distance here and I need to separate it into 5 pieces, 4 marks. 1, 2, 3, 4. Okay, so that's about good. Do a little bit bigger than that. To shade. That one is too big. Okay, we'll just go with this. Okay, so Carmen is 1/5. Alright, so she's going to be yellow. So there's Carmen's age right there. The next thing says that if Bill is B years old, what is Dana's age? Oh, whoops, I must have missed something. Dana is 4 years older than Carmen. Okay, so yes, that one's important to have. Dana has Carmen's age right here, plus 4. Should probably be about this big. Because it's the same as the other one. Do 4 years in pink again. Dana will be green for his age. All right. Now, if B is Bill years old, if Bill is B years old, then how old is Dana? So we know that this is B. Okay, how old is Dana? Okay, so let's take a look at what we have here. Let's check each one by level. So the connection to Bill to Dana goes through Ann and Carmen. So Bill is B years old. Ann is 4 years older than that, so B plus 4 years. Okay, so that's how old Ann is. And Carmen is a fifth of what Ann is. Okay. So it's B plus 4 all over 5 years. And Dana is 4 years older than that. So Dana is the B plus 4 over 5 plus another 4 years. Okay. So we can say in the end, thus Dana is B plus 4 over 5 plus 4 years old. Where B is Bill's age. Now Bill's age represents a number, so therefore we can say B is Bill's age, or the number of his years. Okay. All right, so there's that one. Please let me know if there's any other questions.